Okay, in this session we're going to talk about Windows 7 application compatibility. So in your company, you may be tasked with fixing any applications that have issues when your company upgrades to Windows 7. So this is the session for you because we are going to talk about the major application compatibility problems that can occur when you are upgrading from either Windows XP or Windows Vista to Windows 7. And then for each of these top compatibility issues, I will talk through what exactly the problem is, what's changed between operating systems, and then we'll talk about how to actually debug these in your applications and then how to fix them. My name is Jennifer Marsman, and I do have a blog and I am on Twitter, so feel free to reach out to me if you have any questions following this session. All right, so this session is typically presented as the first session of the day at a Windows development boot camp, and I struggled with making this the first session of the day because it's kind of like, welcome to Windows 7, here's all the stuff that can go wrong, and that's not a very good introduction to Windows 7. So I just wanted to take a second here and call out there is a whole bunch of really cool new stuff in Windows 7 and a whole bunch of new features that your applications can take advantage of as well. So I did just want to kind of mention some of these other things and let you know that they are available as well. We're going to talk about them in future sessions during the Windows Development Bootcamp. But in this session, we're going to cover most of the stuff in the left-hand column. So things like version checking, a whole slew of new security tightening features that were introduced in Windows Vista and Windows 7, such as UAC redirection, UIPI, session 0 isolation. Those things are all security features. And then we'll also talk about high DPI and installer detection and stuff in this session right now. But then if you look at the second column, the right-hand column, you'll see that there's a number of other things that are other very cool new features as part of Windows 7 that your applications could leverage as well. Things like the taskbar and the ribbon and sensors and location and multi-touch. So there's a lot of really cool functionality in here. So do feel free to check out the other sessions in the Windows Development Bootcamp content as well when we'll get into some of that cool stuff too. All right, so what are the top application compatibility stumbling blocks when you're moving from Windows XP to Windows 7? So note this is moving directly from XP to 7, no Vista in between. The top things you tend to see are, first of all, version checking. And what I mean by that is if you hard code something in your application, like if the application version equals Windows XP, well, obviously if that's in your code anywhere, and then you try to move to Windows 7, then that if block is never going to be entered because you're not on Windows XP anymore. So we have done some stuff to help with scenarios like that. But at the end of the day, you probably just don't want to write that code. But that's the version checking problem. There's also something called user account control, or UAC. This is something that was introduced in the Windows Vista timeframe and continues forward into Windows 7. And essentially what the UAC does is that even when you are logged in as an administrator on your machine, most of the time you're not really an administrator. What happens is you run most of your applications with a standard user token, and then when you want to do something with administrative privileges, you request those privileges from the operating system, and then you're automatically granted them because you are listed as an administrator on the box. And then just for the lifetime of that process, it will run with administrative privileges. And then if you go back to other things, those will just continue to run as standard as well. And so along with this whole UAC tokens and such, there's also something around data redirection. And that's really what we're going to focus on today, is the data redirection section. Next is a concept known as the Windows integrity levels, and something called UIPI that you can use, where essentially things that run with a lower integrity level should not be able to call processes that run with a higher integrity level. So we'll talk a little bit more about that. And then the final thing is session 0 isolation, and we will dive into that as well. Next, there are several things you can keep in mind when moving from Windows Vista to Windows 7. Again, version checking could still be an issue if you're still doing explicit checks for the Windows Vista operating system, you're still not going to get return true ever on that. There are several manifest changes, and then high DPI is one thing, but just taking a step back, I know there's a lot of text on this screen, but taking a step back, honestly, if your application works well on Windows Vista, chances are it's going to work pretty well on Windows 7. The application compatibility between those two operating systems is very, very high. Really high DPI is one of the big things. There were a couple of low-level binary changes as well. But if you're a typical application developer, those likely won't affect you unless you're doing very, very low-level stuff like writing antivirus software. But for the most part, for most application-level developers, it will not affect you. Okay? All right, so now let's cover those top issues that I just discussed for Windows XP and Windows Vista. For each of these major issues that I mentioned, we will talk through not only what is the problem, so what is it that changed and made the problem occur. Then secondly, how do we debug and diagnose this problem and find this problem in our applications? And then lastly, how do we fix the problem? All right, so let's kick off with version checking. I have a secret to tell you. Windows 7 is not actually Windows 7. Windows 7 is actually Windows NT version 6.1. And the reasoning behind this is that essentially for the operating system version, there is both a major version and a minor version number. So for Windows 7, the major version number is 6 and the minor version number is 1. And the reason for that is because we have seen time after time after time that one of the big problems that people have when they are upgrading their operating system is this version checking problem, where they're essentially hard coding checks for a particular operating system version in their code. So one of the things that they did to try to counteract that is if people were doing checks and saying if the operating system version equals 6, so that would be the major version number, that will continue to work with Windows 7. Since they did not increment the major version of the operating system. They only incremented the minor version, 6.0 to 6.1. All right? So that's one little thing that may help you. But in general, I think there are some best practices that are even more effective. So version checking best practices number 1 is that applications should not perform operating system version checks at all. So instead, what we recommend that you do, the official Microsoft guidance, is that if an application needs to find a specific feature, just look for it. Try to use it, see if it's available, and then if it's not available, have a graceful degrade situation. I'll give you a code example of that in just 1 second. And then secondly, if the application is valuable without the needed feature, then don't block the whole application just for one little feature. Like oftentimes what you'll see is something where you have an application and maybe one little button in one corner, that 10% of your users use, actually uses a specific feature that's part of the operating system and requires a certain operating system version. If that's true, then don't block the whole program from installing or the whole programming from running without that operating system version. Instead, maybe just do the operating system version check at the button level, and then when the user clicks that button, we'll either have the button grayed out if it's not the right operating system version, or allow the user to click the button and then just surface a little dialog box back to them that says, in order to unlock this functionality, you need to upgrade the version of the operating system, something like that. So disable those as advanced features, but don't block the whole application from running or installing. All right, so I said I would show you how to check for a feature using some code here. So before I kind of walk through this code, there's a little background info I want to give you. The first is that there is a method called setWaitableTimerEx, and this is new in Windows 7. And there's also another method called setWaitableTimer that has been available since at least Windows 2000. So it's been available for over 10 years, it's been in a bunch of the operating systems. So an example of how you might check for a feature is, first of all, try to use this Windows 7 version. So we're trying the latest version where we're trying to call the setWaitableTimerEx. And If that does not work, it will throw an exception. If it can't find it, we'll catch that exception, and then in that code, we will use set waitable timer as a fallback, because we're pretty guaranteed that the operating system that we're using is going to, if we know that we're using Windows 2000 and later, then we know that that is going to be available. Otherwise, you could always have another catch after that and degrade even further. Okay? All right, and then the second best practice is that if you choose to disregard best practice number one, and you just, there's enough things that you're doing, you're using a lot of functionality that is part of the operating system, and you just really need an operating system version check in there, then okay, go ahead and do it, but do not use equals equals. Make sure that you're always checking that the application accepts version numbers that are greater than or equal to the minimum supported version. So in this, and here's kind of the opposite of that, which is we're doing a check if the operating system version is less than version 5.1, which just happens to be Windows XP. In that case, we're going to pop up a dialog box that says Windows XP or later is required. And then exceptions to this should be relatively rare. All right, one last trick I wanted to teach you is something called Compatibility View. So in order to access Compatibility View, it's this little dialog box that you see on the right-hand side. In order to access it, you can right-click on any executable or any shortcut to an executable, and then select Properties, and then in the Properties box, click the Compatibility tab. And you'll see here this nice little Compatibility Mode option. So check this checkbox right here, and it says run this program in compatibility mode for whatever. So if I'm running this particular application that I'm looking at the properties on, so this verge.exe app, I'm running this executable, and I'm running on Windows 7, but I can use a checkbox and then say run it in compatibility mode for Windows XP Service Pack 3. And then essentially what that will do is when this version.exe asks the operating system, what operating system am I running on, the operating system essentially plays a Jedi mind trick on the app. You know, this is not the operating system you're looking for. Instead, what it does is essentially send back the settings that, hey, you're running on Windows XP SP3. And so the application is like, okay, great. And then if it is doing one of those version checks, it will pass the check and be able to keep going. All right? So that's essentially what compatibility mode does. Now, the next question I would be asking if I were you is, okay, Jen, that's all well and fabulous, but I work for a company where my apps are used by 3,000 people I have to roll them out to. And I know I could send an email to all those people about having to right click and check a box and whatever, but half of them are going to delete that email and not even read it. Half of them are going to do it wrong or get confused, and then the rest of them are going to, call me and want help, and I don't want to support all that. So is there an easier way to roll this out programmatically to a large group of people? And the answer to that is yes. There's something called a version lie on compatibility fixes. And this is more of an IT professional thing than a developer thing, but it is relevant here, so I wanted to mention it to you guys. You have to download something called the Application Compatibility Toolkit, which is also called ACT. You can do a search for that using your favorite search engine, Bing, and it should pop right up. And then one of the tools inside of the Application Compatibility Toolkit is something called the Compatibility Administrator. So if you open that up, you can actually create a new application fix that will package up one of these fixes and then apply it to a group of, to an application that's on someone's machine. So let me actually just show you how to do this. I'll walk you through the process. I have that on my machine installed right here. It goes under Microsoft Application Compatibility Toolkit is where you'll find it. And I'll just grab the Compatibility Administrator, as I said. Yes, I'm going to allow it to run. And then here on this, I'm just going to right click on this new database and select Create New Application Fix. And first of all, it's going to ask me for some program information for the program that I want to fix. So I'm going to first grab a program. And right here, this is just a random Windows Workflow app I wrote a while back when I was playing around with Windows Workflow 4.0. So I'll just grab that, and then I'll call the name can be Workflow app, the vendor, I can call it Jennifer Marsman LLC, even though it probably belongs to Microsoft because I did all the IP with a Microsoft machine and probably on Microsoft time, so probably Microsoft owns that IP, but anyway. Let's see. Okay, so compatibility mode. So you can see now on this next screen, I get exactly the same thing that I would have gotten by right-clicking and selecting that compatibility tab from the properties list. So I can click this, run this program in compatibility mode, and then you see I have all of these options of different operating system versions, all the way back to Windows 95, which is, 15 years back, over 15 years old. So that's pretty cool. I am going to select, let's say, Windows XP Service Pack 3. I know that works for me. Then I can select that. And then there's a whole bunch of other different compatibility settings as well that you can see in here. You can disable various things, like disable these fade animations if you know that it works on XP, and maybe the fades and arrow and some of the cool stuff that was introduced in Vista and 7 aren't working for you. I could maybe, check this box. And there's documentation on all of these on TechNet. There's a nice long description of all of these there. And then I can do a test run right from here if I'd like, but I'm just going to move on to the next screen. And this next screen is also very, very similar to the previous screen. You can see I already have 20 things out of 365 selected. That is just because on the previous screen I selected the run in XP mode. So it does some things for me automatically to make it look like Windows XP Service Pack 3. But essentially, these are various things that behave differently on different versions of the operating system. So if you find specific problems and changes in the way things have been done, you can do things to kind of simulate older versions of the operating system here. So if I just kind of run through this really quickly, you can see there's a bunch of correct various things where it will correct parameters that are done differently. There's various delay things that you might see right here. Delay these various things. Disable a bunch of things. There's emulate various things to emulate how things behaved in other versions of the OS, etc. Force, a whole bunch of different force things. So a whole bunch of things you could say. And again, documentation for all of these on TechNet. So go ahead, and if there's additional problems, you can go through and select some of these to fix those problems. And again, you can do a test run from here if you'd like. And then finally, on the last page, what we get is the matching information. So what we want to do here is say, now that I have this application fix, tell me what program I should apply it to. And so in this case, it's selected a number of things for me already: the file version, product version, company name, etc. of my application. If I wanted it to queue on additional things like the size of my workflow app, I could do that too. Of course, that's not something you'd want to do while you're still in development, because the size could change. But again, if you're still in development, you probably shouldn't be doing application fixes. You should just fix the problem right in the source code, as opposed to using this tool. But I digress. So just choose what things you want it to match on, and then what it will do, I can click Finish, and what that will do is then create this little SDB, which is this little custom database. And then there's actually an awesome article also on TechNet on how to package this up and roll it out programmatically, so you can actually create an MSI that gets rolled out to your whole organization. So if you're interested, just feel free to ping me, and I'm happy to provide you a link to that article, which is really good. Okay, so that is the Compatibility Administrator and how that works. And we will jump back to the slides. All right, so we just went through version checking. The next thing we're going to look at is the user account control, or UAC. And specifically, we're going to focus on the data redirection aspect of the UAC. So here's the actual problem. In Windows 7, standard users don't have access to write to certain directories. They have read-only access to the Windows folder, program files, the C drive, or system root, really, and a whole bunch of other locations on your hard drive. Standard users can write to anything under like My Documents and those places. And then the same thing is true for the registry. A standard user has read-only access to HK local machine, although a standard user can write to HK current user and some of those hives instead. All right, and all of these things, both the files and the registry, are controlled by ACLs, or access control lists. So the problem here, obviously, is that you suddenly, where before a standard user could write to all of these different locations, they can't do that anymore. And so one paradigm that may be fairly common, I know I used to do this when I was a developer all the time, is write out log files very commonly to help me with debugging later. When my application was doing something, I might kind of spit out some data to a text file, and I'd usually just stick that text file in the same directory as my running applications. That way I could easily find it. And the problem here is that my application was typically installed somewhere under program files. So now, if in Windows 7 you tried to run my application as a standard user, and then you as a standard user were then trying to write out to that same directory under program files where my app was trying to write to, that wouldn't work quite right. And a lot of people do this. So to get around that, they actually added some virtualization or data redirection, where they do still, it's not going to fail. For 32-bit applications, it will still write something out, but it writes it out to a different place. That's essentially the problem. And then the same thing applies to the registry as well. It's not just the file system. For the registry, you can't write to HK local machine / software or any of those things. In that case, you would have to write to HK current user or something like that. So what's going to happen is, again, for 32-bit applications only that are not marked as UAC aware, I'll talk about what that means in a second, Windows is going to virtualize access to this per user location, and I'll tell you where that is in just a second. And for 64-bit applications, this data redirection is not going to happen. In that case, it will just try to write the file out, and it will fail with an access denied error. That's the actual problem. In the virtualized case, so this is the case of 32-bit applications that are not marked as UAC aware, what's going to happen is that file or registry access to these restricted locations, such as the system root, the C drive, under program files, under the Windows directory, etc., is going to be virtualized. So you try to write something out under program files, and what it will do is actually put it in this per user virtual store folder. And that will be located at C users, whatever your standard user account name is, app data, local, virtual store. And then under there, it's actually going to create a directory structure based on where you were trying to write it to. So if I was trying to write it to, program files / my really awesome app / logfile.txt, then it would write it to this location / program files / my really awesome app / logfile.txt. That's where it would actually get put. All right, same thing with the registry, only in the registry's case, the per user location is HK current user, software, classes, virtual store. Now, there's actually a couple of problems that can happen here, of course. The first is that these files and registry keys are becoming per user instead of being shared between users. If I install something to HK local machine, chances are the reason I'm doing that is because I want everyone who uses the machine to get that setting as opposed to just one user. And by this virtualization happening, it's no longer getting put there. So that can be an issue. And then the second issue is just the fact that data is being saved to unexpected places, right? I expect it to be saved here, and instead it's going over here. So that could be an issue for you. One thing I do want to call out explicitly, though, is the virtualization does work both ways. If, for instance, you're saving off some state or maybe some settings for your app, and you write them out, and then later you try to read them back in, it will look in that virtualized location when you're doing the read as well as the write if you're running as a standard user. So that will actually be taken care of for you. The read will work as well as the write. Okay, and then one final thing I want to call out is that this virtualization or data redirection, it is a temporary solution. Do not ever write any code that depends on it working exactly this way. This is something they put in there just because a lot of people were writing, log files to the same directory as their running app and things like that. So they wanted to put that in here so a whole bunch of legacy apps would not break, but this will be removed in some future version of Windows. So don't ever write any code that depends on it. Just this is a temporary solution. Eventually, you should rewrite your code so that it can be run properly by a standard user. Okay, and then the problem in the non-virtualized case, so this is the case of either 32-bit applications that are marked as UAC aware, which again I'm going to talk about in a sec, or this is the case for 64-bit apps. And so in this case, you're just going to get an access denied error. As a standard user, you will try to write out to one of these forbidden locations, like under program files, and you will just get an access denied. All right, so how do I diagnose this? I have listed every incantation of access denied that I could think of right here under these error message things. So here's kind of some of the symptoms you may see. Other things you might see is just the application crashing or hanging, or data not being saved, obviously, where you think it's going to be saved. Now there's some great tools to help debug this. Windows, the sysinternals process monitor is fabulous, and I'm actually going to walk you through how you can debug this using the process monitor in just 1 second, step by step. And the Lua bug light, I've had less experience with that one, but I've heard that's also very, very good. All right, and then how do we go about fixing it? So there's a couple different things you can do. First of all, instead of writing things out under program files or under the Windows directory or under one of those forbidden locations, change it to write out to some place that the users do actually have permission to write to. There's a great, in the .NET framework, this environment.special folder, which is very cool. It gives you the path to things like My Documents and things like that. And so that will give you the path to common application data, which is one great place to store these things. So you can use the app data or the local app data environment variables if those would work. And then whenever possible, use HK current user instead of HK local machine in the registry scenario. However, I realize that there are times when you want a setting to apply to all users on the machine, so you do need to use HK local machine. And in that case, what you could do is refactor your HK local machine access to an elevated process so that your process, your regular application, can be run as a standard user just fine. And then when you do need to write to the HK local machine, part of the registry, then you just call a separate process that's running, and that process can be running with admin privileges, and then have that access the HK local machine. All right, so now that you know how to fix it, I do want to call out a couple more debugging tricks that can help you with this particular issue. First of all, one great debugging trick is to just go to the virtual store folder or registry key and look for your stuff there, right? Duh, very simple. So if you think that this issue may be occurring with your application, then just go and check. Again, I again pulled out the paths for you here. It's the local app data virtual store if you're using the file system issue, or the HK current user software classes virtual store if in the registry scenario. And secondly, you can try running the application elevated, and you can do that by right-clicking the app and selecting Run as Administrator. And when you do that, you're now running it as an administrator instead of a standard user. And in that case, this data redirection is disabled, so it no longer exists. So you can write to privileged locations just fine. So if you're running as an administrator and everything works just fine, and then you try running as a standard user and things are not working, then that may indicate that this is one of the issues. Now, one caveat I do want to call out, just in case you do use this trick, is that let's say you were running as a standard user and maybe you stored off some settings, and so those settings would have gotten written out to the virtualized store under that virtual store location. And when you're still running as a standard user, it will read from that virtualized store location as well. However, once you're running as an administrator, that data redirection no longer exists and your application doesn't know anything about it. So if you now right-click and run as administrator trying things and you're like, hey, how come it isn't finding those settings that I just wrote out? The reason is because it got written out to the virtual store, and now that your application is running as an administrator, you don't know anything about the virtual store, so it's just looking in the old location, which is that forbidden location, and it may not find it there. Okay, so just keep that in mind as a little gotcha that you might run into if you're using this trick. And then finally, you can add a UAC manifest to disable virtualization. So I've mentioned this UAC manifest thing a couple of times. What this is essentially an application manifest where you can tell the operating system that you know about the whole UAC thing and you're good. And so what that means is when you say, I am UAC aware, and set that to true, then the operating system says, oh, okay, you know about this whole UAC stuff, and by setting that to true, you've said that, okay, I've dealt with it myself, and so the operating system will say, fine, I won't do the data redirection or that virtualization for you, since you've told me explicitly that you know what's up. So in that case, what will happen is that it will just try to write to the forbidden location, and you'll just get an access denied error if you didn't fix your code. So one thing you can do is, even if you didn't do anything to fix it yet, you can add in a UAC manifest and say that you are UAC aware, just to disable that data redirection, and then you will get an access denied error, but then you can debug that fairly easily. Just go and look at the line of code that access denied error is being thrown from, and be able to pretty much find the issue pretty quickly. All right, the next thing I wanted to show you is that process monitor. So I mentioned this very briefly before as one of the great tools you can use to identify this problem. So first of all, you can download process monitor from sysinternals. That's sysinternals.com. For the kind of the fun story behind sysinternals, it's a company that was started by a guy by the name of Mark Russinovich. If you don't know Mark Russinovich's history, he's a very technical fellow at Microsoft, a very, very bright guy. And he actually had a company, WinInternals, way back when. And Microsoft actually bought the company because he knew his stuff very well, and he became a part of the Windows core engineering team for a long time. So he's the one responsible for Process Monitor. And this is pretty cool stuff. So you can download it from sysinternals.com, as I said, and that will actually redirect to a Microsoft site now somewhere under TechNet, I think, since Microsoft rebought the company. So what you're going to do is when Process Monitor, when you first launch it, you're going to get this dialog box that you see right here, this Process Monitor filter. And so what you're going to do is, first of all, set up the filter to only include events that are coming from your application's process name. So the way you can do that is say process name is, and then whatever your process name is, put it right there. And then in that case, we want to include it in the filter and all the stuff that we're doing. So do that and then hit add, and then it should add a line like this into your filter so that it will just grab the stuff from your application. Okay? Then, once that's set up, we want to enable capturing file or registry events. So you can do that using these things right here. And then press, again, Control E will toggle whether or not you're capturing events, essentially. Control X will clear the log, just a little bit of documentation. And then finally, just run this scenario in your application, which may result in that virtualized write or that data redirection, while all of these capturing of events, of file or registry events, is enabled. And then once you've run it, you can go ahead and look at the results. You should see some stuff like this in the Process Monitor tool. And in the results column right here, look for operations with the result reparse. So if I go down here and I see this reparse right here, you can see what I'm actually trying to do right here is a create file operation. And then it also gives me the path. So I'm trying to create a file or write a file out to C program files, ACL broken app, sumfile.txt. And that's resulting in a reparse. And then if I look at the very next line, you can see this one was actually successful. And what it does is that same create file operation, only it's doing it in C users, standard user, app data, local, virtual store, and then this path copied over, the program files, ACL broken app, sumfile.txt, and then that was successfully done. So this tells me that this issue occurred, and then it gives me the exact path of where that data redirection actually put my file. So very, very nice, handy tool that you can use to help debug this issue. So to kind of summarize what I just said, if you see the reparse operation, that usually tells you that this data redirection or this virtualization did occur. That next line with the result of success will give you the new path. And then you can also double click on the reparse operation and click on the stack tab, and that will show you something a lot like this. And in this case, then you can use this is the call stack, when that reparse operation occurred. So you can use this to find the exact place in your code that's responsible for the write to that forbidden location. Okay? All right. So the next thing we're going to talk about is something called User Interface Privilege Isolation, or UIPI. And the thing that drives me absolutely crazy about UIPI is the fact that it has to do with something called integrity levels in Windows. And it drives me absolutely batty that there are two I's in UIPI and neither one of them stand for integrity. But my therapist and I are working through it, and it's going to be okay, I guess. But still, come on, people. Okay, so there is this concept of integrity levels. It was introduced actually in Windows Vista and carries forward into Windows 7. And what it means is, by default, a process with a lower integrity level cannot send a Windows message to a process with a higher integrity level. And this, of course, is a security feature, right? If I downloaded something from the internet, that's going to come with essentially a lower integrity level assigned to it. So we don't want that internet process to be able to then call or send stuff to a process running with admin privileges that can, take over my machine and be able to tell it what to do. So this is just called UIPI, and it's a security feature to help things out here. So what is the problem here? So you will see this when UAC is turned on. If you turn off UAC, then this will actually go away. But again, like I said, processes running with just their standard user privileges are going to run with normal integrity level, and it's actually called, in the tools, you'll see it called medium integrity level. And then processes running with admin privileges are going to run with a high integrity level. And then, of course, sending or posting messages from stuff with lower integrity levels to higher integrity levels will fail, except for a few cases around like the UI and some other stuff. So how do we go about diagnosing that this is a problem? You should see this access denied may be probably the most common thing that you'll see. There'll be some kind of message sending or posting, and it'll fail, and it's usually an access denied error that's returned. And then we can use a tool called Process Explorer to help debug this further. And Process Explorer is another tool from sysinternals.com that you can download for free. And I recommend running it with admin privileges. And the reason I recommend that is because it will show you, it's a lot like a task manager where it shows you all of your running processes and a whole bunch of information about them. And if you run it with admin privileges, then you can see all of the processes that are running, including the ones that are running with admin privileges and below. If you just run it as a standard user, so you just double click it and run it normally, you'll just run as a standard user, and as a standard user you'll only get to see the standard user processes and below. So you won't see actually everything that's going on in your machine, because there is some stuff with admin privileges running as well. Then you're going to add a column for integrity level and check the relevant processes. So I'll actually show this to you. Here's just kind of a quick screenshot of it, but I will show it to you for real by going here. It's Process Explorer, like so. Right click and run as admin, as I said. Do I want to allow it to make changes? Yes. And then here's another Windows 7 trick. If you don't know this, you can actually grab this guy and shake, 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 shake. And what that will do is minimize all the other windows that are open on your machine. So I can shake it again, shake, 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 and then all the other things come back, which is kind of cool. So it's a neat Windows 7 trick if you haven't seen that before. So this is Process Explorer. You can see it's a lot like a task manager, where it gives me all of my running processes and a bunch of information about them. Now by default, you're not going to see this integrity level column. I think it only shows you these columns by default. So to get this integrity level column, you need to right click on the columns and select this select columns. And under process image tab, you will see a whole bunch of different things. And so go here to this integrity level and check the little checkbox there and then hit OK. And I've already done this, so I'm going to actually go down to the bottom. Here's the stuff that I actually started. And you'll see all of the stuff that's running on my machine right now, which is an awful lot of stuff. And in some cases, you can see things like this Internet Explorer stuff. So stuff that's downloaded from the internet tends to run with low integrity level, right? Because you don't want stuff that you've gotten from the web to be able to do bad things on your machine. And then things that I'm running just normally that I just double click to run will run with standard user privileges or medium integrity level. So you can see when that PowerPoint presentation that we were just walking through is running with medium integrity level. And then remember how I right clicked and ran as administrator Process Explorer? You can see Process Explorer actually runs with a high integrity level because it's running with administrative privileges. So now, once you can clearly see the integrity level, this is pretty easy to debug, right? All you have to do is say, okay, I know that this process is trying to call this process and send a message. And obviously, if this guy's low integrity level and I'm trying to send to this high integrity level, then there's going to be a problem. That's just not going to work. Okay? So pretty simple to debug. All right, so how do you go about fixing this problem now? So if possible, first of all, try to run your relevant processes with standard user privileges. Don't have things run as admin just because they've always run as admin, etc. If at all possible, let things run with as a standard user and not as an administrator. And then, of course, if you have something that's standard user calling something else that's running as a standard user, their integrity level will be the same and you won't have any problems. But we know that this isn't always the case. In some scenarios, you do have to have your stuff run as an administrator. So in that case, what you can do is in the code of the higher level process, you can call this change Windows message filter or change Windows message filter EX, one of those two methods. And what that will do is allow you to receive new messages. Now, I don't actually like the name of this method a lot because in my mind, a filter is something that filters things out. But in this case, when you add a message to the filter, then that allows the message to be received. So it's a little bit counterintuitive. That these are new to Windows 7 and they will allow messages to be received by that specific window. And the difference between the change Windows message filter and the change Windows message filter EX methods is that change Windows message filter works on a process-wide basis, and change Windows message filter EX can be scoped down to just like a specific window. And so change Windows message filter EX is actually the recommended thing that you use just because it's a little more secure. You're filtering it just to one specific window as opposed to any window that's open in that process. So you want to keep your attack surface, of course, as small as possible. And so here's just a kind of a quick snippet of what that might look like. Change Windows message filter, you pass in the message and then comma, and then there's this message filter underscore add constant that you pass in as well. Okay? All right, now that you're all UIPI experts, I know you'll love this super funny joke. If they were both Windows processes, why couldn't Lindsay Lohan call, or send a message to, Mother Teresa? Because she had a lower integrity level. Woo, yeah. Sorry, I'm a dork, you guys. These are the jokes. This is as good as I can do. Okay. Next up is session 0 isolation. Okay, to explain this properly, I kind of have to explain the entire concept of Windows sessions and ensure that you know how that fits into the greater scope of things. So essentially, there is a concept known as a Windows session. And when I log into my machine in the morning, I log in as Redmond/Genmar, and that creates a session for me. And if someone else, if I were to like lock my machine and walk away for a minute or something, and then someone else from Microsoft comes and logs into my machine as well using their user credentials, then they would create another session for themselves. So in that case, we would be running in two different sessions. Then within the concept of session, there is a Windows station. And then within a Windows station, there is a concept of a desktop. And you could have multiple desktops, of course. You can remote desktop into other things. And then finally, within a desktop is where your actual user applications or services run. Okay? So here's kind of the thing. In Windows XP, if I were the first person to go log into my machine in the morning, I would log into session 0 because we're 0 based, of course. And then if someone else were to come in and log into my machine as well, then they would get session 1, and then the next user would get session 2, etc., etc. However, this was changed in subsequent versions. So starting with Windows Vista, the services, all of the services of your machine run alone by themselves in session 0. So if I go up to a Windows Vista or a Windows 7 machine and I'm the first person to log into it in the morning, then I am going to get session 1, and all the services are going to start up in session 0. And then the second person to log in would get session 2, etc., etc. Kind of a big difference there, because before in Windows XP, both all the services that I would need plus all of my user applications and such would all start up together in session 0. And now my applications and such run in session 1, and just the services run in session 0. Okay? So there's actually a couple problems that fall out of this. The first is that Windows messages can't cross desktop boundaries. And if you remember that fun little Venn diagram we just looked at, desktop was a subset of session, so of course they can't cross session boundaries either. The next issue is that kernel objects are private to a session by default. So if you were using any kind of shared memory between your applications and your services, then those are private within a session, by default. So something that may have worked in like shared memory that you may have accessed from services and applications in Windows XP when everything was running in session 0 might have been just fine. But now if you're on Windows 7 and your app is in session 1 and your services are in session 0, then by default they're not going to be able to access the same shared memory. The next thing is that services can't display UI on the user's desktop. So if you have any kind of interactive services that pop up a UI, and then those are services, so they're running in session 0, there is no user associated with the desktop of session 0. Because me, as the first real user logged into this machine, I'm going to get session 1, and so I'm not going to see those pop-ups that are on a different desktop. And then finally, there's the problem of access control. And this is not a direct problem, but it just kind of adds another layer of complexity on top of everything. That, you used to have everything kind of running together, and now your applications are running over here in session 0 or in session 1, and your services are running over here in session 0. So you might just need to do some re-ackling of things to make sure that everybody can access what they were accessing before. Okay? So there's enough problems here that I kind of I'll walk through them one by one when I'm talking about solutions. But first, let me talk about how to identify the problem. Some symptoms you might see. First of all, the fact that no UI is displayed where there used to be some. That is one issue. And of course, that would happen when your services are popping up dialog boxes in that session 0 desktop. And you might also see this interactive services dialog detection, which is part of that same problem. And I'm going to talk about that and show you that dialog box in just one sec. And then your clients may either receive access denied errors or not receive a response at all from services, just because they're running in different sessions now. And then how do we go about diagnosing this? Again, you can use that Process Explorer to see what session things are actually running in. So I can show that to you real quick. If I jump back out to Process Explorer right here, We can see that there's also a session number associated. And again, the session number is not displayed by default. So if I right click, select columns, under process image tab, make sure session is checked right here, and then hit OK. And then once that's checked, you can see here's all the sessions. So here's everything that's opened up in my session. Obviously, I'm logged into session 1 as the only real user on this machine right now. So my PowerPoint, all the things that started by me, or either things in my start menu that just start up automatically for me, are all running in this this session 1. And then if I look up at the top, here's a bunch of stuff running in session 0, and these are all various services and such that are part of session, that are running inside the session 0. So again, unfortunately, you can't access this information right in the task manager of Windows. You do need this Process Explorer tool from sysinternals.com to actually see this. But once you have this, download this free tool, it's very easy to see, okay, I'm calling from here to here, and I can just very easily look at my processes, see what session they live in, and if one is in session 0 and then another one is in session 1, then obviously I know there's the problem. Okay. Back to the slides. One other thing, I didn't actually show you this screen, but these two screens right here, if you're dealing with access control issues, you can also use Process Explorer to get more information on that. The screen on the left is right-clicking on a process in Task Manager and showing its security under the properties, selecting properties and then clicking on the security tab, and you can see kind of the levels of information we get here. And then this is the exact same thing, right-clicking on a process, selecting properties, and then going to the security tab in Process Explorer instead of Task Manager. You can see we get a little bit more information here, the session number, whether it's virtualized or not, a whole bunch of other good information here. So this can help you debug access control issues as well. All right, so solutions. And as I said, I'm going to walk through the solutions in conjunction with each problem, just because there are a couple of different problems at play for this particular issue. The first problem of displaying UI to the user, there's a couple of different solutions here. So remember, this is the problem where we may have a service that pops up a dialog box, but it's doing it in the session 0 desktop, which nobody is actually looking at, and I, logged into the machine, am going to be logged into the session 1 desktop. So Windows did build in some automatic mitigation to this problem. And what's going to happen is it will see that nobody is using the session 0 desktop, and it will actually pop up something on my session 1 desktop that says a program can't display a message on your desktop, and blah, 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 blah. And then there's this show me the message. So I can click on that, and then I will actually be able to get that message. However, this is kind of inconvenient and kind of, hacky looking. So you probably don't want to leave this in here, but it is kind of an easy mitigation thing that you will see. But the way to fix this properly is twofold. For simple messages, you can use something called WTS send message. And some of you may be familiar with that. It's actually something that's used in remote desktoping right now. So that it's the same kind of concept of being able to cross those session and desktop boundaries. So I'll show you a code sample of that in just one second. Or if you want to create a more complex UI client, simpler than just a dialogue with a title and a message in it, you can use create process as user, find that active user, and then create it on their desktop. Okay. So here's the quick code sample for WTS send message. I apologize, this is in native code in C++. I apologize if you're a .NET programmer, but I can kind of walk you through what it's doing very simply. This WTS get active console session ID will tell me what user is actually logged in and actively working right now. And so I will get a session ID here. So in my case, it'd probably be session 1 is being used right now. So that would go in DW session. And then I have this response variable, and I'm just going to initialize that to 0. And then I call WTS send message and then pass in this current server handle constant. the actual session that I just found above, a title for the message box that I want to pass over, then some size information on the title, the actual message that I want to send over in the dialog box, plus some size information for the message. And then I also am passing in by reference here, you see this response variable, which is initialized to 0, and then if there's any kind of error message or whatever, it can reset that to 1 for me, and I can check that after the message completes, or after this function call completes. Okay? All right, then for the problem of access control and integrity levels, there's a couple of solutions here as well. Now, again, remember that this problem is that you may be using some kind of shared memory or shared pipes or whatever, but now your applications are running in session 1, where your services are running in session 0, and if they're sharing things, they don't have permissions to the same things anymore. So there is a very easy fix for this, and it's just essentially modify the ACLs on both sides. Just choose, where you want that shared memory to be, and then modify the ACLs so that both your services and your applications have permissions to access it properly. The next thing we're going to talk about is high DPI. And DPI stands for dots per inch, in case you're curious. So the whole DPI thing, it's slightly different than resolution. One of the problems, the whole reason why high DPI kind of came into play is that with higher resolutions, they're optimal. Like I like running my machine at a higher resolution normally. But the problem with it is that everything gets a lot smaller at higher resolutions. And so with high DPI, what they were trying to do is kind of try to mitigate some of that and make things still have the advantages of, the sharpness that you get at a higher resolution, but still be nice and easy to read as well. And I have this chart on here just to kind of show you that, we work with a lot of the large OEMs, and there's more and more displays coming out with high DPI settings. So you do want to make sure that your app does run well at high DPI settings. Okay? So what are some of the problems that can occur with high DPI? Well, there is some virtualization, again, that the operating system will try to do for you, and sometimes that virtualization will correct some of these problems, or, it could cause some of these problems depending on how your machine is set up. But here are the problems that you actually are seeing. First of all, things like clip text. So in this case, the button text is cut off here where you can't print this page that well. And here we have some text cut off as well. And then we might see blurriness or pixelation. In this case, we have some blurry images. In this case, we have some blurry text, which neither of those are optimal. And then another thing might be layout issues, or things, again, here we have an example of something being cut off, this view status we can't read. And then here, see there's this little icon. This is actually supposed to be aligned with sharing and discovery. Same thing here, this on and off. These little icons are supposed to be lined up with the on and off text, and instead they're kind of slightly above them. Same thing here, this is kind of above the text as opposed to right next to it. So that's kind of a layout issue. And then also mismatched font sizes you might see all kind of sitting together. So a whole bunch of kind of non-optimal display issues may come up with high DPI settings. So there's actually a pretty easy solution to this one. When you're developing native Win32 apps, you can set a manifest setting to say that yes, I am DPI aware, and then scale all of your text and your buttons and all of that stuff using the DPI values that are returned by this this method called getDeviceCaps using this API. And I'll show that to you in just one second. And then for managed code developers, it's even easier. For WinForm applications, you can utilize this auto scale mode property and use, I think the default value is none. And then instead of using none, use font or the DPI values. But really the main takeaway I want you to get, if you take one thing out of this high DPI sessions, it's always test your application on high DPI settings. Just test it to see what the issues are. And I'll show you actually how to change the DPI on your machine in just a second. But essentially, I mean, even if you see, maybe there's a little blurriness or pixelation, but it's something that you can deal with, fine. That way at least you know You've tested on high DPI. You say, okay, there's a little blurriness. Maybe that's not high enough priority for us to fix, but at least we know what the issues are. And if the issues are worse, things like, a button is maybe getting cut off for your UI, where, it makes your app a little bit unusable. In that case, you really do want to make sure that you fix it, but at least just test to see what the issues are and how bad they are and what priority they are. Okay, I mentioned a DPI aware manifest. Here's what this does. It's in your application manifest, and under Windows settings, there's a setting called DPI aware, and you just set it equal to true. And what this will do is, on Windows XP, it has absolutely no effect, but in Windows Vista or Windows 7, there is some automatic virtualization, as I mentioned, and it will scale your applications for you that are not DPI aware. And then your apps are going to get this virtualized data back from this virtualization that will help it account for this high DPI thing. But again, much like that UAC manifest that I mentioned, once you're saying, hey, I'm DPI aware, that will actually turn off this virtualization. You're saying, I'm DPI aware, I know about this, and I've taken care of it myself, and then the operating system will respect that and then not apply any virtualization to your application. All right, but then you probably want to fix it yourself, and then how you would do that is using this get device caps API. So again, I'll walk you through this code. First, we're going to get the actual DPI values, and we do this by calling this get device context method, or get DC, and that will give us a value right here. And then we're going to call this get device caps method twice, passing in the device context right there. And then the first time we're going to call it with a constant log pixels x to get the DPI in the x direction, and then we'll pass it in again with log pixels y to get the DPI in the y direction. And this essentially gives us a scaling factor for the DPI of the particular device that we're running on right now. And then we can release that device context to release that memory. And then when we're actually putting together our UI, we want to scale using the appropriate values. So let's say I have a button and it is a 60 by 26 button. What I want to do now is take that button size in the x direction, times it by that DPI scaling factor in the x direction, and then divide by 96. And the reason I'm dividing by 96 is because 96 is the value that's considered standard DPI. So 96 dots per inch is normal, and then things above that are considered high DPIs. So that allows us to give us the proper scaling factor and to resize that appropriately. Then we do the same thing with the y. We take the y value, times it by the scaling factor, divide it by the normal value of 96 dots per inch. And then we'll get the proper x and y sizes on that device. And then when we create our window, we just pass in the button and then with those appropriate sizes, and we've created it all properly. All right, so pretty straightforward. All right, the last thing I wanted to do is just show you how to change the DPI on your machine so you can test this. And you can configure it using the display window that's part of the control panel. And one thing I did want to call out is they don't give you the actual dots per inch on this screen. And the reason for that is because most people don't understand what dots per inch actually means. So they give you a scaling percentage instead. So essentially what you're going to see is the smaller, medium, and larger. So I've translated that for you right here. Smaller is actually this 100%. That's actually the standard dots per inch, which is 96 dots per inch. And then for these larger DPIs, we have medium, which is the 125% actually equals 120 dots per inch, and then 150% equals the 144 dots per inch. Now, I do also want to call out that the virtualization that I mentioned, where it will automatically kind of adjust things for you, the operating system will automatically do that, that only kicks in over 120 dots per inch. So if you do have your display setting on this medium range where it's 120, you won't actually see the effects of the virtualization at that level. It does have to be above 120 dots per inch for the virtualization to kick in. Okay? And so I can show you how to get to this if you'd like to see. It's part of the control panel, or I can just search for display right here. You can see under the control panel there's this display, so I'll just click on that. you can see for my resolution and screen size, I actually don't even have the largest option available, but I can switch between smaller and medium by clicking on these buttons right here. And then you can also set a custom DPI like so, just by clicking this little guy right here and changing the values. Okay, and we'll cancel that. Okay. Finally, installer detection, the installer detection issue. So the problem here is that installers typically need administrative privileges, right? Because they're writing things under the program files, and as we already saw, only administrators can write things under program files. Standard users cannot. So prior to Windows Vista, installers could usually assume that they run with admin privileges and everything would work just fine. But with Windows Vista and Windows 7, it's running these applications with standard user credentials most of the time because of the UAC factor, and this will cause installers to fail. So they did build in an automatic solution into Windows Vista and Windows 7 that uses some heuristics to guess whether or not a process is an installer. But the problem here is that these heuristics could very well be wrong. And the heuristics actually are, does the process name contain the words setup, install, or update? Yes. So if your process contains any of those terms, then it's going to assume that it's an installer and try to run it as an admin. All right, but obviously there are kind of both false positives and false negatives in that issue. So therein lies the problem, and we're going to see this with again, anything that contains the words install, setup, or update, it's going to assume that it's an installer. But there are two problems here, and these are the problems of both a false positive and a false negative. Some applications might have this in their name, but they're not actually installers. For example, something like a stackupdater.exe that isn't actually updating a program. What it's doing is maybe updating a stock ticker across the bottom of my screen, and perhaps that can run just fine as a standard user. I don't need it to run as an admin, but the operating system is going to automatically try to run it as an admin because it sees the update in the name. And then the opposite problem is that there may be some custom installers. I might have something called my really, really awesome app.exe, which doesn't actually run my really, really awesome app.exe, but instead installs my really, really awesome app.exe. But that's not going to be recognized as an installer because it doesn't have any of those terms in it. So here's how we would deal with this problem. Add a manifest. We are all about the manifests, right? One thing that's kind of cool about this is that you can use either an embedded or an external manifest. And an external manifest is really nice because if you get like a third-party app, you might not have access to the source code, but what you can do is just create something with the name myapp.exe.manifest and then stick it in the same directory as myapp.exe, and it will use that manifest. So that works really well. And then another quick gotcha just to call out is that, remember, if you create something in Notepad, by default, Notepad is going to add a .txt onto the end, and it will not recognize this as a manifest if the name is actually myapp.exe.manifest.txt. So if you're one of those people who hides the known file extensions on your machine, which I know plenty of people do because it's one of the default settings, do check for that as a potential issue if you create a manifest and for some reason your app doesn't seem to be finding it. Make sure there's not a hidden .txt on the end if you created it with Notepad. Okay, and then inside the manifest, what you're going to do is create a setting called requested execution level. And then you're going to set that level equal to something, either as invoker, which essentially tells it have it run as the same level as the creating process. So if you're invoking it as a standard user, it'll run as a standard user just fine. Or you can set that level equal to require administrator, which means it needs elevated privileges to install something. It requires that you have those admin privileges. Okay, and that will tell it very explicitly, here's the execution level that I need. So here's an example of what this looks like actually inside of the manifest file. Right here under this trust info, security, requested privileges, we can just set requested execution level equals as invoker. So that's something you might want to call in that case of the stackupdater.exe when we want to tell it, no, really, it works just fine as a standard user. We can just set that level equal to as invoker, and that will take care of the problem. All right, and then there's a whole bunch of other cool stuff in Windows 7 that we didn't have time to talk about. Background services and instrumentation and performance. There's been a whole bunch of advancements in both of those areas. Plus, there's all of the really cool new stuff that we're going to talk about in some of these other Windows Development Bootcamp sessions. Things like the ribbon and the taskbar and sensors and location and multi-touch, and there's really, really cool stuff in there as well. So hopefully, though, this session gave you a look at some of the potential issues that could occur, and then gives you confidence and give you some tricks for your toolbox on how actually to go about fixing these guys if you should run into any application compatibility issues. Finally, I'm going to give you a couple of resources. I've been compiling a list of all of Windows development resources in general, and so I created a bunch of links on a blog post, and then I've linked to it through this bit.ly link. So you can go to http://bit.ly-genwindev, and there's a whole bunch of good stuff available for you there that will redirect to my blog post on Windows development, and I've been trying to keep that up to date and update it with new things as they come out. There's also the Windows 7 Training Kit. This is an amazing set of resources. It has presentation, hands-on labs, demos, all kinds of things around Windows 7 development inside of it. So do take advantage of that if you'd like. And then the Windows Development Bootcamp, that's the event series that this presentation is a part of. If you would like to attend one in person in your area, you can go to windowsdevbootcamp.com and see where they're coming next. And then, of course, my blog is blogs.msdn.com/Jennifer, and I'm happy to answer any questions as well. All right, finally, if we were running this as part of a Windows Development Bootcamp, what I would tell you guys to do next is, from that Windows 7 Training Kit for developers, there's a Labs folder, and inside of the Labs folder, there are both managed and native versions of a whole bunch of the different issues that we just talked about. So I would encourage you to go through and try out, if you're a managed code developer, which most folks are who tend to attend this session, then you can do the managed version of these, but there's also native versions of these if you prefer to code in C++. But you can check out the version checking, installer detection, UAC redirection, UIPI, high DPI, session zero isolation, all of these things that we just talked about. There are hands-on labs that will allow you to explore this in a little more depth. So feel free to check those out. And if you have any trouble figuring out where they are or how to go through them, just please let me know. I'm happy to help. And that concludes today's presentation. If you have any questions, do feel free to ping me. I hope that was helpful and that this helps you transition to Windows 7. Thank you very much.